Hello, welcome to our Thursday AI show. Every Thursday, we have a different host who live codes some sort of AI application. Today, I'm going to create a JavaScript application that allows you to chat with your custom documentation. So, before we get started, I want this to be interactive. So, use the chat, say hi, ask questions. I'm going to be monitoring the chat as we go. It's going to take about 30 minutes to build this out. But as we go, like something doesn't make sense, raise a question. Let's talk about it. And let's see. Let me know where you're joining from. I'm in Texas, so it's 10 a.m. for me right now. All right, so let me share my screen, and we'll slowly get started. And let's see. Let me make sure I have the chat up over here on this side, and I'll add my screen. Let's change the layout there. Okay, cool. So we're going to base this off of a workshop that we have. This is a self-paced workshop. So if you want to go through this on your own, I learn by hands-on, so by doing things. So if you want to actually run through this on your own after this, that would be amazing. And I'll put a link in the chat here. Let's see, that's only going to go to YouTube. So let me also put the link in LinkedIn. I'll comment over there on LinkedIn as well, if you're joining from LinkedIn. All right. So hello, everyone. I see some people in the chat there from Ireland. And awesome. Okay. So we are going to kind of run through this workshop. We're not going to go through every little step here. But again, like I said, if you want to go through this on your own, that would be amazing. It's a great way to learn. So I'm going to assume that you already know what MongoDB Atlas is. We're going to use Atlas in this application, and specifically, we're going to use vector search. So if you haven't already created your account, created a cluster and all of that, there's some instructions here on how to do that. And then we have the section about OpenAI. So we're going to use OpenAI in this application, but you can use any model provider that you'd like. We're just going to use OpenAI because it just makes things easy. And but this will work with any of them. So again, this kind of goes through like what is OpenAI, how to create your OpenAI account, and get an API key. The next part here is the documentation, the application here itself. So this is based off of a Next.js template that is, let's see, let's go ahead and open this up here in another tab. So this is based off of this LangChain Next.js template. So it includes Next.js Tailwind, OpenAI, LangChain, and the Vercel AI SDK. So that's what we're going to be starting with. So we're not going to completely start from scratch. We're going to start with this template here. So in addition to this template, we are going to add the MongoDB package here. So to make things even more simple, we have another GitHub repo. Again, there's links within this workshop that you'll want. So again, I put the link to the entire workshop in the comments in the chat. So this GitHub repo is basically an extension of that original template, and where we just add a couple of extra things, specifically some workshop assets, which we're going to get to a little bit later. But basically, this is that Next.js template with MongoDB added with some extra assets. All right, so to really get things going, we can git clone this, cd into that directory, and then install. So I already ran through this bit here. So this is where I stopped. I'm at this bit where I've cloned it and run npm install. Cool. So now what we need to do is configure the application. So in the environment variables, there's a .env.example file. So if I go over here, you'll see a .env.example file where we need to enter our OpenAI API key and our MongoDB Atlas URI, or our connection string. And so you can find the connection string over here in Atlas, and I am in my database here, and I can go to my cluster here and click connect, and then I will see different ways to connect. And then we're going to use drivers. And so this right here is my connection string. So you'll want to copy that. Of course, make sure that you put in your username and your password that you set up during your cluster creation. Again, those steps are back in the workshop a little bit earlier. We kind of skipped over those. But you get your connection string, and you enter your OpenAI API key. And then, let's see, we go down here. We can, this kind of just explains what I just showed you, how to get your connection string. And then we can test the app. So let's go ahead and do that. So again, this is just that, that second repo that we looked at with some extra, little bit of extra bits in it. Well, I'll walk through what those extra bits are. But basically, this is just the next JS template. So let's go ahead and open that up in npm run dev. And then let's just go ahead and go to localhost, localhost 3000. And there's running. So it's very, very, very basic. So at the bottom, we just have an input here. So we could say something like, what is MongoDB? And this is basically just ChatGPT. So this is going to use OpenAI and answer your questions. It's going to answer your questions based on the model that we're using's data that it was trained on, right? So this is a pretty generic answer. Like, this is accurate. What is MongoDB? Popular open source, document-oriented, NoSQL database, etc. Yeah, so pretty good answer. But what we want to do is we want to be able to answer questions based on our specific documentation. So if I go back here, and remember there was some extra bits in this repo, workshop assets. So in workshop assets, we have some fake docs, and I used ChatGPT to help me create some fake documentation for a fake JavaScript library called FancyWidget.js. So FancyWidget is a modern, lightweight JavaScript library for building interactive UI components. This is completely fake news. So like, this is not accurate, but ChatGPT helped me create a bunch of fake documentation, stuff like API reference, changelog, installation, license, usage, quick start. So all of the documentation that you would expect from an open source library. So we're going to ingest and vectorize this information so that we can ask questions about this, because ChatGPT and other models, they don't know anything about this this JavaScript library that we created, right? So we have to give it some custom information, some extra context, so that it can answer our questions about this library specifically. So let's go back to our workshop here. So we've tested it. It works out of the box. Great. So the next bits here talk about full text search, and then after that we talk about vector search. So just to kind of give a high level difference there that between full text search and vector search. So full text search is keyword. So if we go into here, you can do keyword searching, you can do scoring. There's different language support, autocomplete, highlighting, etc. But it's very, very much based on keywords. And so we look at some capabilities here. You've probably heard of Elasticsearch, Solr. They're all based on Lucene. And our full text search is also based on Atlas search is based on Lucene as well. And so again, how does that work? We have to have those exact words. It's keyword searches. So it has to be very, very close. There's a thing called fuzzy search, so it can be a little bit off, but basically you're looking for that exact word. And so if we go over to the next bit, the difference in what we're going to be using today is vector search. And vector search is semantic, meaning that you don't have to have the exact keyword. So first of all, like if you asked for, let's see right here, it says how to make a cake. So if you used keyword search, it's going to look for these words, how to make a cake, exactly, one-to-one. But with vector search, it could return how to bake a cake. So making and baking, that's very similar. How to make a pie and a cake, they're pretty similar. So it might return answers like that. So similarity, semantic search is what vector search is. And so let's talk a little bit about vectors. So if you're not familiar with vectors, they are a numerical representation of whatever data you are creating vectors for. It could be text, could be images, video, and so on. And so basically it is an array of numbers. So a vector can have It's basically an in-dimensional space where in represents the number of vectors or number of numbers in the array, right? So popular number is 1536, 1536 vectors. So depending on which embedding model you use, it will have a different amount of vectors in the array. But basically, that's what it is. A vector is an array of numbers. And so we use those vectors during vector search to find things. So if we plot things out like this in, this is basically 2D, but imagine 1,536 dimensions that can be graphed and plotted out, right? So we have this plot here, and then what we're searching for is in this spot within the graph. So the closest thing would be 1 here, right? But there's different ways of searching. And there's Euclidean, which searches the closest ones, like closest. So it will actually go down into this vector down here. So 1 and 4 would be the closest. But cosine is a little different because it won't go back or down. It will only go up and to the right. So we got 1 and 3 if we used cosine search. And then there's many different types of searches as well. So we're not going to go into details into all the different types, but that's the overall very high level view of how vectors work. And so when we go in and I'll show you in the documentation or in the application here that we're going to be using LangChain to facilitate a lot of this because LangChain just makes it easy so that we don't have to write a lot of boilerplate code. So what we will do is let's go to the embeddings part. So the first thing that we have to do is, again, we talked about this virtual space where we're going to be searching for data. We have to put our custom data into that virtual space so that we can search it. So what you'll hear this referred to is embeddings or vector embeddings or vectors, right? So we're going to create our embeddings for our custom data and then store them in MongoDB. So you'll find a lot of the code here in the workshop assets folder as well to help you along the way. But what we're going to do is take a look at this create embeddings.mjs file, which let's just go ahead and go over to VS Code. It's a little bit easier to look at. So create embeddings.mjs. This is less than 40 lines of code. So this is a Node.js script that we're going to run that will ingest our data. So let's just kind of step through this. And again, if you have any questions, I'm monitoring the chat over here on the side. And actually, let's see, I think my head is probably in the way of, I'll just remove myself there so you can see all of the code on the screen. So let's look at this. So first of all, we're pulling in the file system promises from Node.js, and then we're using the recursive character text splitter from LangChain. This is going to allow us to split our documents into chunks. And we'll go into why that's necessary in a bit. So we're also going to import our OpenAI embeddings from LangChain, MongoDB Atlas Vector Search, and our Mongo client, and then .env for our environment variables. So the first bit here is we're just setting up our database connection. So we're connecting to MongoDB. We're creating our client here using our connection string. We're going to name our document or the database that we're going to connect to. We're going to name that docs. The collection is going to be embeddings, and then we're just setting up that collection here to use later. So we're connecting to that database and that collection here. Next, we're going to get our fake docs. So this is docs directory, and again, that's in our workshop assets and then fake docs. Then we're going to get the file names for all of the files in that directory using the Node.js file system, and then just console log the file names. Then we're going to loop through those files. So we're going to, for each file, we're going to read the file, and then console log that we're vectorizing that file. And then we are going to split that file into chunks. So recursive character text splitter in LangChain can accept many different types of files. We're going to specifically tell it that this is a markdown file. So because it's a markdown file, LangChain knows that it has a built-in hierarchy of sorts. So it has headings, it has paragraphs, right? So it's going to split this document into chunks because the document itself could be really, really long, and we wouldn't want to create a huge embedding for this huge document. So we are going to split it into chunks, and there is no magic number here. You kind of have to, it's very much use case dependent. So we're splitting it into a size of 500 with an overlap of 50. We want to just make sure that the key here is to make sure that you have enough context in each chunk. So you don't want them to be too small, but you also don't want them to be too big. So again, kind of trial and error depending on your use case. So then we get our output from that recursive character text splitter. And we're going to pass that output, all of these chunks, into MongoDB Atlas Vector Search. And they go right here. And then we're going to create embeddings for them. And then we're going to tell it where to put these. So we're going to tell it the collection that we set up earlier. That's where to put them. Tell it the index name. The text key is the field within the collection where the raw text from that chunk is going to be stored. And then the embedding key is the field in the collection where the embeddings are going to be stored. So the embedding, again, that's just an array of numbers. So two fields here, the raw text and the vectors. And then we'll just console log that we're done and close the connection. So let's see. I'm just looking over at the chat real quick. Let me put my face back up so you can see me. I don't see anything in the chat. Again, let me know if you have any questions as we go. So we are going to go ahead and run this. So let's go ahead and open up our console. Let's just open up another terminal here. And I think actually in this, there is a, let's go to the package.json. I think there is a script here. Yeah, embed. Embed is just going to run node create embedding. So I can just do npm run embed, and it should run that script. So it sees all of those files and very quickly vectorized each one of those and closed the connection. So let's go ahead and go over to MongoDB and let's see what happened. So again, back here in Atlas, we're going to go to browse collections on my database. And then I've got the sample databases here, but we see this database called docs and embeddings. And here are the embeddings that it just created. So we have, again, the, well, of course, underscore ID, but we have our text field, which is the raw text chunk from this markdown document, and then embeddings. So the embedding model that we used, the Ada02 from OpenAI model, it has a 1,536 numerical vectors in the array. So if I actually expand this, you'll see just a bunch of numbers, 1,536 numbers. So these are the actual vectors that we're going to use. And then along with that comes some extra metadata. So the location of this chunk from which document that it came from. So we can tell where this chunk actually came from. Extra metadata that LangChain provided for us. So all of that saved here in this collection. And so let's go over to our workshop. So we ran the script. We looked at the embeddings. So the next thing that we need to do is create a vector search index. This will allow us to define how we're going to use these embeddings, these vectors, during search. So the key thing that we need here is this. So I'll just go ahead and copy that. And let's go over to MongoDB Atlas again. And if we go up here to Atlas Search, we can create a new search index. And then go to the JSON editor for Atlas Vector Search. And then I'm going to paste in what I copied there from the workshop. So what we need to do here is, first of all, on the left side, select which collection we're creating the search index on. So that's going to be under the docs database, the embeddings collection. And then the index name, I'm just going to leave it at the default vector underscore index for the index name. And then here we're defining how this index should work. So the fields. So this is the type of vector. The path is embedding. So we're telling it which field contains our vector embeddings. We're telling it how many dimensions, 1,536. This will change dependent on which model you use. The model we used includes 1,536, so it needs to know how many dimensions are we dealing with here. And then the similarity search type. Remember, we talked about there are many different search types. Cosine is, I would consider cosine the default, but there are others that can be used here. So we're going to now go ahead and save this or create this vector search index. And then let's go back up to our workshop. And the next thing that we need to do is update our API routes in our application. So before we do that, let's go ahead and just look at what is here currently. So again, this is a Next.js application. And if we go under API, this is, again, just what came with the standard Next.js LangChain template. And so nothing has been modified here. So let's take a look at this. So this is our chat route, and it uses LangChain to separate the AI messages and human messages. So here we have our main post route, and we get our messages. So this is actually a message queue that gets tracked. And so when the user submits a new message, that will be pulled here from our request. And then we're going to get our LangChain stream and headers, create our LLM, create our chatbot basically here, and then call the chatbot, passing it those messages. So we're going to separate the messages to human messages and AI messages, and then send that to the LLM that we use. In this case, we're using OpenAI. Then we have our streaming response. We return our streaming response, which streams the text back to the client, so that it's not just one wall of text, and it sees the text coming in as the response is sent from the LLM. All right, so this is 29 lines of code, and this is what came with the template. So we're going to modify this, because this takes the user's question and sends it directly to the LLM. What we need to do is intercept this, and we need to add some extra context to it, because if we're asking questions about our custom documentation, the LLM doesn't know about that. So we have to add this extra context, and that's where vector search comes in. And just to take another step back, this is what's called retrieval augmented generation, or RAG. You might hear it referred to that as well. So we are going to, let's go back to the workshop. And what we'll do is we're going to create this vector search route here. And so let's just copy this code, and then we'll work through that. So I'm going to go over to our API route here, and we're going to create a new route called vector, let's see, vector search, and then I need a route.ts file. So in this, let's see what we're going to do. Again, very short file, 35 lines. This is going to be our vector search route. So we're going to use OpenAI embeddings from LangChain, MongoDB client, and then the MongoDB Atlas vector search method from LangChain. If I haven't said this before, MongoDB has a native integration with LangChain. So it makes things very, very easy. So again, we're going to set up our MongoDB connection, just like we did in that Node.js script where we ingested our data. We are going to connect to our database and get our collection set up so that we can use it down here. So here's our DB config. We have our collection. We have our index name. Remember, we created our index and we left it at the default name, which was vector_index. So we have to tell it which one. The text key, where are the raw text chunks being saved? So that's called text, the text field. And then the embedding key. So the embedding field is called embedding. So that's where the embeddings are. So we're telling it where all the things are. And then we're setting up our vector store using MongoDB Atlas vector search. We're creating OpenAI embeddings. And the reason that we're doing that is because we have this question here, the question from the user. And so in order to use vector search, we have all of our custom information stored in this virtual space. we also have to put the user's question into that virtual space so that we can answer what's the most similar answers to this question. So we have to create an embedding for the user's question. So that's why we're creating this OpenAI embedding here with the user's question, so that we're putting it into that virtual space and then running vector search. So here is our retriever. So using our vector store, we're going to use something that's called a maximal marginal reference. It's just a search type. There's different types, but this one is going to fetch the 20 most relevant documents and then return 10%. So basically, it's going to find 20 and return the top 2. Again, no magic numbers here. Use case specific. Play around with these different types of search types as well. So this is just what we're using in this example. So then we get our results and then respond with those results. So getting the user's question, creating an embedding for the user's question, sending that to MongoDB vector search to find the most similar chunks, and returning that. That's the basic premise there. So let's go ahead and save this. And the next bit that we're going to look at is, so we created that route. We have a chat route, which is our standard route, and we have our vector search route. So we created that. We need to now, like I said before, intercept the question and then send it to that vector search route and return some results from there. So let's go back to the workshop, and there's some more code here that we can use. So here is updating that chat route that we just talked about. So there's a bit of extra stuff here. I'm going to copy. It goes down to over here. Okay, so let's go back over to. Oh, there's some questions. Let me go over to the chat real quick. Is it going to be find the top 2 or randomly select 2 from the top 20? No, it's going to be the top 2. Yeah. And it can be anything. So you can take. So like I said, there's no like magic bullet here. Everything can really be anything. Everything can be changed. So what you can do is you could return the top 20, and then you could re-rank them in some way, and then return the 2 that you want, the 2 that make the most sense for your use case. In this case, it's returning the top 2, not random 2. But yes, it can be anything. You can do anything that you want with it at that point, because there's different search types. There's different things that you could do in the pipeline to change up the results and how it returns the results. So what we're doing in this use case is just returning the top 2. All right, so again, right here, we're getting the user's message from this post route. So this is our chat route, getting the user's question, and we're going to intercept that. So right here, I'm going to paste that extra code, and let's talk about it. So what we're doing is, here's another question that just came in. Which type of index, hang on, let me show that. Which type of index or setting searches the whole vector DB? Yeah. So this is the index that I set up here is going to search the vectors in the collection that I set it up on. So in the whole database, you're going to have multiple different collections. So that means you would have to have multiple different indexes, because an index is based on a collection, right? And a collection can have multiple indexes as well. So it really depends on how you set up your specific use case, how you set it up. But yeah, you can set up multiple indexes if necessary as well. Okay, so here we're intercepting this message. Again, this is a queue. This is an array. This message is here. So we're going to get the current message, because there could be multiple messages in this queue, right? So we're going to get the current message. So we're going to pop off the last message from the message queue so that we know that we have the current message. And we're going to send that to our vector search route that we created. So vector search here, we're going to fetch from that route, that API route that we created. And this is going to return to us the results of that vector search. So it's going to return to us the closest chunks of data from our database that match the question that was asked. And then this is kind of the magic sauce here, in my opinion. A little bit of prompt engineering goes into this. So this is a template here that we are defining what we want to do with this. So we're going to say, you are a very enthusiastic, fancy widget representative who loves to help people. Given the following sections from the fancy widget documentation, answer the question using only that information, output it in Markdown format. If you're unsure of the answer and it's not specifically written in the documentation, say, I'm sorry, I don't know how to help with that. So then we're adding the context, which is the results that we got back from our vector search. And then we're adding the user's question, that current question. So all of this is what's now going to be sent to the LLM instead of only the user's question. So we're telling it what to do. We're giving it that context from vector search and the original question. And then we're going to push that back on to the messages queue right here. This template, we're adding it back on to the messages queue. And then the rest of this is just business as usual. We're just going to send it on to the LLM after we've intercepted and added that extra context. So let's save that. And now this should still be running. Yeah, it's still running in the terminal. So if I go back to my fancy widget docs here, remember we asked what is MongoDB? It answered us based on ChatGPT basically. So let's go ahead and just refresh this. And let's ask it something that we know it shouldn't know. What is the fancy widget library? And let's see. Oh, there we go. Oh, well, it kind of went off the screen. That's interesting. Well, that's a design issue there, but it answered. Fancy widget is a modern, lightweight JavaScript library, yada, yada, yada. Okay, so we could now, because we're using Vercel's AI SDK, again, we have this message queue. We have history built in. So we could, instead of saying, how do I install fancy widget library? I could just say, how do I install it? To install it, so it knows our entire context, our entire history. I don't have to specifically say, how do I install fancy widget library? How do I install it? It knows we're talking about fancy widget library. And so here is, it pulled this again from our custom documentation, how I install it. Of course, this isn't a real library. Again, by the way, this is just something that was made up. But it knows. So then if I ask it again, what is MongoDB? Let's see what it answers. Sorry, I don't know how to help with that. So we know that the LLM knows the answer to this question, but because we specifically said only answer based on our custom information, otherwise say, sorry, I don't know how to help with that. So it's following our directions. It's only answering information from our custom documentation. And so that is, let's see, let's go back to the workshop. So we updated that, we tested it, and yeah, that's the end of the workshop here. So again, like it's been 30 minutes. We kind of flew through this. If you want to go back and work through this and really kind of see how it works hands-on, I would suggest that. Again, I put the link in the description or in the chat as well. Looking over at the chat to see if there's any other questions. I'm working on MongoDB, both works Redis. I'm not sure. Okay. Yeah, let's see if there's any other questions coming in. But if we go back to, again, the collection here in our database, again, this is what it was using to retrieve our information. And, well, spinning. So what it does, again, it uses the vectors. There we go. It uses the vectors here in our embedding field to find the closest chunks, but it actually returns the text. So the text is what gets returned. And then when we go over to, let's see, it was in this route. No, it was in this route, the chat route. So it returns the actual chunk of text, and that is what gets put here under context. So it uses the array of vectors to find the chunk and then returns the actual chunk of text that we can then pass into this custom template that we sent over. Cool. So just looking over at the chat again, I don't see any specific questions. Also, like, let us know if there's any use cases that you'd like to see us build an app for. Is there any like specific problems that you're running into anything that you need help with. We'd love to build things and answer questions about real world examples and use cases. So if you have something, that would be awesome. Let me go over here to the chat. I think there's another question. Okay, yeah. So for example, I would like to compare a reference document in the vector to other documents in the collection. Would that be able to iterate through the whole collection? Oh, yes, exactly. So if you have, you have to create embeddings. So if you have, I would like to compare reference document to the vector for other documents. Okay, so there's specific things within your documents that you have to create embeddings for. So what is it that you're trying to search for? That's the first question. And then let's say you have books. You have a books library, and there's descriptions for each of the books, right? And so you want to use vector search to search through these descriptions in your entire collection. You create embeddings or vectors for those description fields. So your description field will be your raw text, and you'll have an embedding field for that description field. Vector search would use the embeddings for every document in that collection to find the closest related documents and then return the descriptions from the matching documents, right? So it does search through the entire collection of embeddings to find the most closely related ones. Yeah, I hope that answers your question. But yes, it will iterate through the whole collection. Awesome. Well, that is going to be it for today's show. Be sure to check back with us next Thursday. Every Thursday, we have a different host building a different application. Next Thursday, I believe we're going to be looking at Python. So, which most AI developers use Python, so JavaScript is kind of the oddball. But we're gaining more traction. So again, let us know if you have any questions. Come back next Thursday. Hope to see you soon. Thanks again.